For thousands of years, human movement depended on natural power. Horses, camels, carts, and boats defined how far and how fast people could travel. Distance meant effort, time, and limitation. When the first automobiles appeared in the late 19th century, they were not welcomed as a revolution. They were loud, unreliable, expensive, and often dangerous. Many cities considered banning them entirely, believing they would never replace animal-powered transport. At that stage, a car was nothing more than a metal frame with an engine attached, lacking comfort, safety, or reliability. Driving required physical strength, mechanical knowledge, and a high tolerance for risk. As the early 20th century began, mass production changed everything. Factories like those introduced by Henry Ford made cars affordable for ordinary people, not just the wealthy. Roads expanded, cities grew outward, and cars reshaped how humans lived, worked, and traveled. Despite this progress, cars remained purely mechanical machines. There were no seat belts, no airbags, no safety testing, and no concern for environmental damage. Speed, size, and horsepower were celebrated, while accidents and pollution were accepted as unavoidable consequences. The car gave freedom, but it demanded sacrifice in safety and sustainability. By the mid-1900s, cars became deeply tied to personal identity and culture. They symbolized independence, success, and modern life. Highways connected entire nations, and suburban life was built around personal vehicles. Yet this era also revealed the darker side of automotive growth. Traffic deaths rose dramatically, fuel consumption increased, and cities became crowded with noise and exhaust fumes. Governments slowly began introducing safety laws, not because manufacturers wanted them, but because society demanded protection. Seatbelts, crash testing, and emission standards marked the first time cars were designed not just to move people, but to protect them. The late 20th century marked a turning point where intelligence began entering the automobile. Electronics replaced purely mechanical systems, allowing cars to monitor their own performance. Anti-lock braking systems, electronic stability control, fuel injection, and onboard diagnostics transformed driving from a raw experience into a controlled one. Navigation systems removed uncertainty from long journeys, while sensors started assisting drivers with parking and obstacle detection. For the first time, cars were not only responding to human input, but also making small decisions on their own. At the same time, concerns about oil dependency and climate change forced the automotive industry to rethink its future. Electric vehicles, once dismissed as impractical, slowly gained attention as battery technology improved. Early electric cars faced limitations in range, charging speed, and cost, but they proved one important idea: cars did not need to rely on fossil fuels forever. This realization marked the beginning of a shift from mechanical power to digital energy systems. Today, cars have evolved into highly complex technological platforms. Modern vehicles contain millions of lines of software code, constantly processing data from cameras, radar, and sensors. Advanced driver assistance systems can maintain lanes, adapt speed, detect pedestrians, and even take control in emergencies. Electric vehicles are becoming more affordable and efficient, while charging infrastructure continues to expand. Cars now receive updates wirelessly, improving performance long after they leave the factory. This is something no past generation of drivers could have imagined. We are now standing at the edge of a new transformation. The future of cars will not be defined by speed or design alone, but by intelligence, connectivity, and autonomy. Self-driving technology aims to reduce human error, which remains the leading cause of road accidents worldwide. In controlled environments, autonomous vehicles are already operating, learning from real-world data every day. Cars of the future will communicate with each other, with traffic lights and with entire city systems to optimize traffic flow and reduce congestion. Ownership itself may change. Instead of buying cars, people may subscribe to mobility services where autonomous vehicles arrive on demand. Urban areas could see fewer private cars and more shared transportation, reducing traffic and pollution. Rural regions, on the other hand, may adopt autonomy more slowly, blending human driving with intelligent assistance for decades. The future will not be uniform. It will evolve differently across regions and economies. However, this transition will not be instant or perfect. Ethical decisions, legal responsibility, cybersecurity risks, and infrastructure challenges must be solved before full autonomy becomes normal. Humans will continue to play a role in driving for many years, especially in unpredictable environments. The future of cars is not about replacing humans, but about supporting them, reducing mistakes, and increasing efficiency. When we look back at history, the evolution of the car mirrors human progress itself. We moved from muscle to machines, from machines to electronics, and now from electronics to intelligence. Cars began as tools, became symbols, and now are transforming into partners in mobility. This future is not fantasy. It is grounded in technology that already exists and systems that are rapidly improving. The road ahead is long, but the direction is clear. This is not science fiction. This is futuristic possible.